Hey everybody, I'm back and we're going to look at one area problem that involves algebra, and then the rest of these will be sort of algebraic. Um, so this is kind of pre-algebra problem, so it's good to start developing your algebra muscles. So this shows a trapezoid, and if you haven't learned those geometry problems, you can do basic geometry at Khan Academy and learn about shapes. They want us to write a simplified expression for the perimeter of the figure in terms of x. Okay. That's a bunch of mathematical sounding stuff, but perimeter, if you don't know, like some of you may have been in the military, so you know a perimeter line is the line that goes around a building or a compound or an encampment. On the GED formula sheet, they tell us the definition of a perimeter for several different shapes. Of course, they don't list one here for trapezoids, but basic idea is all the same. You add up the length of each side, and then you have the perimeter, right? So they're trying to scare you with an intimidating picture here, but all they do is change the numbers. So if you get the idea of how to do these, you'll have a good chance of getting it right. So basically we have to add 1. Here's a friendly little number. And then we have these algebraic looking things, x plus 4, negative 2x plus 5, negative 5x minus 4. We just have to add those together. This plus this plus this plus this will give us the distance around, even though these units don't seem to make sense. So let's take a look at that. This formula sheet may be useful for other things, but not until we get into slope. And then Pythagorean theorem, we'll do that in geometry. Quadratic formula, quadratic equations. Those are like Math 56, 57. You have something to look forward to. Anyway, when you take the GED or any of my tests, you can use this GED formula sheet. Okay? So you don't have to memorize all these things, but you do need to be very familiar with them, right? You're not going to be able to learn math from this sheet during a test. You have to go in knowing it all. All right, let's take a look at this problem. So we've got a trapezoid. One side is 1, and we're getting the perimeter. And another side is x plus 4. And another side is negative 2x plus 5. Oops. Hey. My goodness. All these technical things. 2x plus 5. Make sure I don't write this wrong. And then negative 5x minus 4. Okay. So sometimes what I suggest students do, because it can get confusing with all of these, you got some signs and some operations. We're just going to write in the signs that aren't there, make that a positive, and then we're going to just look at all of these. Oops. And we're going to see which of these are similar. We have to combine like terms. So whenever you add or subtract anything in math, anywhere, fractions, decimals, exponents, scientific notation, you have to have, the numbers cannot be combined, they cannot be added or subtracted from each other unless they have something in common, and it's usually the units. They have the units in common. So we have whole numbers here. We have, right, just numbers. Positive 1, positive 4, positive 5, negative 4. So we can combine all those, right? So let's do positive 1 plus 4 plus 5 minus 4. So if you're thinking, these two are going to cancel each other out, right? So we have 1 plus 5. That's 6. So this number is already looking a little bit easier. So our first term here is 6. And then we're going to combine. We've got an x, and we never write it 1x, and we never say it 1x, but you can imagine there's a 1 there. And that's actually harder than it sounds. But if you can tell yourself when you see an x that that's really a 1x if you need it to be, it'll help you later. So we've got 1x minus 2x minus 5x. And that's quite a bit of negativity. I'm going to go green. So 1 minus 2 is negative 1. So, and then minus 5 more. So 1x, or x minus 2x, x minus 2x minus 5x. So x minus 2x is negative x. And then minus 5x is negative 6x. So then we just have to put these two together. We have 6 minus 6x. And because this is subtraction, but these are not like terms, you cannot subtract 6x from 6 because they have different units, right? One is just a number and one is a number with a variable, so that gives it a different unit. So they have to stay separate. This is as simple as the expression can get. So let's put it in here and see what it says. 6 minus 6x. Syntax okay? All right, let's submit it. Okay, awesome. So don't be afraid of that problem. There is another one here. I tried to get rid of it, but there it is. And it's 1x minus 2, 4x minus 5, and negative x minus 3. So very similar. You can try it on your own and just combine the like terms. And that's a mathematical thing, combine like terms. And it always refers to addition and subtraction. And you can never, ever combine terms in math unless they share something in common. It's just a rule. Multiplication, division, all bets are off. You can do whatever you like. But addition and subtraction is sacred. All right, let's take a look at the next one, Q14, according to my notes. This will be more Algebra E. So start a new sheet. We've got negative 5x plus 3 minus 4 times 2x minus 1. Okay. So I always like to write in the operations just so we're aware. Operation awareness. So we do have a multiplication here going on. And we only see, hey, it's doing it again. All right. Come on, help me. Stop mirroring. Start mirroring. Wow. It times out, and then my tablet falls down. All right. I can't figure out what's happening. It was working fine until an hour ago. Okay, so when you see a negative sign like this, you can think of it as negative 1 times that whole thing. So the same way we have like a negative x, we don't say negative 1x, we just say negative x. You can just put a negative sign in front of this, and it's effectively a negative 1 multiplied against this polynomial, right? So let's go ahead and, you guys remember the distributive property? We're going to distribute this negative 1. So normally with PEMDAS, right, we're going to try and combine. We're going to do the math in the parentheses first. But you know what? These are reduced as far as they can go. They can't be combined because why? They are not like terms. So what we're going to do is something called expanding. We're going to expand this out, and we're going to use the distributive property to get in there and multiply 5x by negative 1 and multiply positive 3 by negative 1. And then we're going to do the same thing over here. And this, we're going to consider it to be a negative 4. And we're going to multiply it that way. And if you pull the operation in, use it as the sign for the number, it will save you grief later. Trust me. So we just want to put the operation with the number and consider that the sign and then combine. So negative 1 times 5x will give you negative 5x. Negative 1 times positive 3 will give you negative 3. And then over here we have negative 4 times 2x. It's like ads jumping up everywhere. Negative 4 times 2x will give you negative 8x, and then negative 4 times negative 1 will give you positive 4. So this looks a little more manageable, right? At least I hope it does. So now we are going to combine like terms. Let's start with the numbers because they're easier. Of course, you could scan for multiplication or some other operation going on, but it's there's just subtraction, two subtractions and one addition. And we know we have to have like terms together in order to add. So we're going to put these two together over here. Let me grab another color to make this super fancy. And we're going to grab these two with the x. They have the same units, so they can be combined over here. So negative 3, positive 4. It's 4 minus 3, leaves 1. Let me give a better, bolder color. How about blue? Blue. So these two combined to leave 1, positive 1, right? And over here with negative 5x, negative 8x. So both negative, it's going to be a lot of negativity. Add the 5 and the 8 to get 13. You got negative 13x plus 1. All right, so let me write this a little bit nicely, a little bit more nicely. There's our answer. And let's see what they say. Negative 13x plus 1. Syntax okay, awesome. All right, fingers crossed. Good. I don't know what I'd do if I made one more mistake. So number 16, I think, is another multiplication type problem using negatives. So remember in each one of these, I don't see one here, but they do have dividing into 0. Remember that answer is 0. And usually they have a division by 0 where you have to write in undefined. But maybe because it doesn't say undefined, this doesn't include that. So make sure you know your rules for positive and negative numbers before you take that test. And this should go really, really quickly, right? Negative 2, and use the tab key to get around, and then 35, and then negative 14, and then what is that? Hang on, stop. Okay, this was addition. 7 plus negative 2 is a 5. I was just thinking it was all multiplication. 9 minus negative 5, 9 plus 5 is 14. 0 divided by negative 3 is going to be 0, no matter what, and no sign on 0. Negative 6 minus 2, so you're at negative 6 and you're going to go 2 more negative. It's going to be negative 8. And then 4 times negative 9, signs are different, so negative answer. Negative 36. Negative 7 times negative 9, negative 63. Negative 5 minus negative 6. That's like negative 5 plus 6, that's going to leave 1. Negative 21 divided by negative 7, that's going to give a positive answer, which is 3. Negative 8 plus 9, that's like 9 minus 8, which is 1. Just like the other one. 8 divided by negative 4 will give us a negative answer, because the signs are different, negative 2. And then negative 9 plus negative 2 is like negative 9 minus negative 2. Oh, excuse me, negative 9 minus 2, so it goes a little more negative to negative 11. All right, let's see how I did on those. Awesome. So really work on your multiplication table if you don't have it down cold, because when they start adding negative and positive ideas, you can't afford the distraction. All right, moving on to the next algebra problem. That was just like a little sorbet to cleanse your palate. And now a little more algebra. 2b, or not 2b, 2b plus 11b minus 7 times 3b plus 6. All right? Okay. So PEMDAS, what are we thinking? We have parentheses, right? We've been here before. Do you remember what to do? So we can't combine these, right? It's addition, and they are not like terms. So that's as far as we can go. But our secret weapon, we're going to use the distributive property. Distribute the negative 7 over these two and evaluate that. So we're going to get negative 21b minus 42. Right? So if you got your multiplication table down cold, awesome. And then just write down the rest of this, 2b plus 11b minus that. All right? So we got rid of all the scary parentheticals, right? So now we've got, and you could put the sign in if you want, positive 2b, positive 11b, negative 21b, and minus 42. And there is no common term, no like term for 42, so it's just by itself. But we can combine 2b and 11b, right? That's going to give us what? Since this is just addition and subtraction, we're going to go left to right. So 2b plus 11b, 13b. What could be easier? Minus 21b. So signs are different. This is positive. Positive. This one's negative. So take the difference between the two numbers, which is 8. We've got 8b, and the bigger number, 21, has a negative sign, so the answer will also have that negative sign. It's like they inherited the negativity of the parent. So negative 8b, and then we have to bring this number down, minus 42. So that should be our answer. It's a little bit messy. Oops. All right, let's do it this way. Do it right or not right at all. Hey. Minus 42. Is that what I said? Yeah. All right, let's try putting that in there. Negative 8b. Another way I made a lot of mistakes early on. This one was right. So when I lived in Japan, they were always really careful about writing. And when they write math out, they would make their X's like this, and their Z's would look like this. And so it wouldn't look like a 2. And write your numbers and letters carefully, because they will come back and haunt you. B is always cursive like this, and a 6 is like this. So you can distinguish a B from a 6, or a Z from a 2, right? And some people write a Z with a line here and a 2 like that. So if you can think of a new way to write your letters that will make it less ambiguous, that'll be good, because you don't know what variable they'll ask you to use. But if any of these, if I thought any of those was a 6, I wouldn't have gotten the same answer I got. All right, moving right along. Question 20. All right, let's get a new page. See if it's up there. 4x plus 2y minus 4x plus xy minus 2y. All right. Pretty straightforward. This is just beginning algebra. So what do we want to do first? So I'm going to write in the signs, and then I'm going to block it off like that. And so I'm going to ask you, which of these is a like term? And so we'll go first. Let's just start with this. We got 4x and negative 4x. So these two are a pair. We're going to switch colors. It's going to be dramatic and exciting. 2y, positive 2y, negative 2y. Hey, are you seeing stuff cancel out like I am? And then we got this one guy right here all by himself. Okay. So what's positive 4 and negative 4 together? 4 minus 4 is going to be 0, right? So these are going to cancel out and leave 0x, which is the same as 0, right? So nothing. If you want me to write in 0x, I will. And then positive 2y, negative 2y is going to leave 0y, which is nothing. And then we're going to have positive xy. So in our next evaluation, I'll use blue. We're going to have these evaluate to 0 or nothing, and then this is just plus xy. So our answer could be this. Let's see if it's right. XY. So basically they're just testing you to see, my syntax is okay, awesome. They're just testing you to see if you can analyze and apply rules. Okay. Submit. Awesome. Okay. 2 more. Okay, the expression 5 times 4x squared plus 4x plus 2 minus 4 times 6x squared plus 4x plus 5 simplifies to. Yes. If we knew the answer to that, we would all be millionaires. Or actually, teachers living on the poverty level. So what we're going to do is use the distributive property. So you probably have already guessed these are not like terms in here, so we can't do anything. We can't do what PEMDAS would have us do, right? They can't be combined. So we're going to use a different technique and distribute this, because we have 5 times this whole expression. That means 5 times each of the individual parts of the expression, right? And we're going to write those out. So 5, this is positive, and this one is negative. So they often do that. Like one's positive, one's negative. So keep your eyes peeled. So 5 times 4x squared will give us 20x squared. And then 5 times 4x will give us 20x. 5 times 2 will give us 10. And then over here we've got negative 4 times 6x squared is going to be negative 24x squared. Negative 4 times negative times positive 4x, negative 16x. Negative 4 times 5 will give us negative 20. And now do you remember what to do? Let's put in a sign here. And just, I left out a sign. Anyway, this was 5. 5 times positive 2, so that's a positive 10. Yep, so I didn't need that sign, but I'm going to use it now, because I just want to have everything labeled positive or negative. Because then we're going to combine them. So, where's all our x squareds? We only have 2x squared. So, this positive 20x squared, negative 24, we can combine those. So, positive 20x squared I'm not writing very coherently. Positive 20x squared minus 24x squared. So 20 minus 24 is going to give us a net loss of negative 4, negative 4x squared. Plus 20x minus 16x, the difference is 4, right? And the 20 is bigger with a positive sign, so it's going to be plus 4x. And then 10 minus 20, different sign, so take the difference, which is 10. And 20 is bigger than 10, so negative 10. So negative 4x squared plus 4x minus 10 is what this can simplify down to. So we have distributed these numbers across both expressions, and then we've combined the like terms. So it's kind of like reducing fractions on steroids, because there's so many different things you have to do. Now here's the fun thing. When you guys have to type your answers in, I don't think we've typed in an exponent yet today, but to type it in, some of you may have done that math typing exercise. When you want to type in 4x squared, you need this caret key, which is an uppercase 6, and it could be 4 cubed. The machine doesn't care, but this one is squared, so that's how you would write that. And then plus 4x minus 10. Right? Syntax okay. So all of this seems to simplify down to just this, much more manageable, which is written more nicely this way, right? Okay, but we have to do it this way because we have a keyboard. All right, let's see how we did. Oh, awesome. All right, so this one is another one of those perimeter problems, so I'll leave that to you to try and figure out. And when you run your practice test, it'll have different numbers, so go ahead and give that a try. If you run into trouble, come see me or go to the Math Learning Center. But yeah, last one. This is an order of operations problem. All right, let's do it. 5 plus 4 times 8 plus 3 minus 4. All right, so PEMDAS, right? Parentheses. Exponents, multiplication or division, addition or subtraction. So we have parentheses with an operation. So exciting. So we've got addition, we have unwritten multiplication, we have addition, and we have subtraction. So we have to go in the parentheses first. So 8 plus 3, we're going to evaluate that first. That's 11. And then just bring everything else. I'm going to leave 11 in parentheses. And then just because I love to do colors, plus, times, and minus. So we're going to have to do the multiplication first, 44. And then we have 5 plus that minus 4. And addition and subtraction are on the same level, so we just go left to right. 5 plus 44 evaluates to 49. Minus 4, this evaluates to 45. And that should be our answer. Let's see. Is it going to be a good day or a bad day? Awesome. Okay, well maybe I'll just throw this one in and see if I can get them all right. Although I did have to take 2 chances to get that one right, where I thought it was subtraction instead of division. All right, so perimeter. We add up the length of the 4 sides, no matter what the units are. That's the length. That's the fun of math. 1 plus x minus 2 plus 4x minus 5 plus negative x minus 3. And earlier, when I did the first one, I suggested putting each term in parentheses. So you're adding this all together to get the perimeter, right? Sometimes, like if they had said, these are the distances, what's the perimeter? You would just say 1 plus 2 plus 3 plus 4 and evaluate that. This would be 3 plus 3 plus 4. 3 plus 3 is 6, plus 4, and 10. Right? You wouldn't think anything of it. So sometimes if you come up against a problem like this, like, wait, what? Just try to look at it like if it's a decimal problem, think of it as money. That'll really help sharpen your focus. And if you see something like this, try to use the substitution technique. Just put regular units in there to pick apart the process, because that's often where we get stuck. We can't see the process. So that was just a little advice. Traveling through time. All right, so now we're going to do this thing where we look for here. So let me put the signs in. So we've got positive 1, positive x, negative 2, positive 4x, negative 5, positive. So here we have plus. When you add a negative, it's like just adding. It's like adding a negative is the same as just subtracting. So we get all the signs in. So this is just saying to combine. Combine a negative x and a negative 3. So these are all lined up now. What I like to do is just chop them. So what numbers can come together? We have positive 1, negative 2, negative 5, negative 3. Okay, so 1 minus 2, negative 1, minus 5, negative 6, minus 3, negative 9. Okay, and then we have all of these units with x's. Positive x or positive 1x. Remember to see that 1 there. Positive 4x, negative 1x. So if you guys are really on your toes, this is mutual self-destruction. These two will just cancel out. So we have negative 9 plus 4x. And generally, when we write equations like this, polynomials, we will write we'll write 4x minus 9. We often go, if there's an exponent, we have the highest exponent on the left, and then we write gradually until we get down to just what we call the constants, okay? So it won't affect the answer because 4x minus 9 is the same as negative 9 plus 4x, but I'm going to write it in this way just because I'm OCD. 4x minus 9, my syntax is okay. Is this going to be it? Oh, awesome. I'm ready for the midterm, at least for Unit 1. All right, I'm going to go over Unit 2 also, but give Unit 1 a try and come see me if you run into trouble. I've got office hours. Tomorrow we have class, so we could talk about. I'll go over some of this in class tomorrow. But Wednesday I have office hours. I have office hours whenever you need me to. And then there's the Math Learning Center if you're shy. But please don't be shy. Come see me. Let's learn this before the test. And at least be able to do Unit 1. You know, if it's too much to try and do Unit 1 and Unit 2, we'll take care of Unit 2 when the final comes. One advantage of the Emporium format is that we just want to try and finish Unit 1, then we're going to try and finish Unit 2. If you can get them both done at the midterm, awesome. Then we'll move you into pre-algebra. If you can't, then we'll keep working at this level till we get Units 1 and 2 done. Simple. Okay, just keep trying and come see me when you need help. All right, that's the end of this video. See you around.